get through this, people. Let's get through this. So we are moving on to Unit 4. Okay, here we go. Quadratics. This is a big deal. Close your Chromebooks. Close your Chromebooks. Quadratics is actually going to take us 2 units. The good news is you should have no snoring. You should have learned some of this stuff in Algebra 1. I know it's been a minute. I'm aware. But hopefully some of this, by the time I kind of reteach it to you, you're like, oh, I have seen this before. Especially today, because it's transformations, and I know you saw it 3 weeks ago. You saw it last class too. Anyways, final things about Unit 3 and this quarter. Like I said, the retest, you have Tuesday and Wednesday. If you're choosing a retest, come in, look at your test, see what you did. Y'all, the last time we did retests, I gave out so many retests, and maybe 10 people did better. So if you are planning to retest, you need to come in, see what you did, actually do some intervention in between now and then. If it was a small mistake, okay, that's one thing, you can just kind of learn from there. But if you bombed it and it was bad, you're going to need to do something in between. Otherwise, again, we're wasting time. So retest window are going to be next Thursday or Friday. Those are the final 2 days of quarter 1. Okay, so quarter's over next Friday. 8:30 or second half of power lunch. Those are the retest opportunities. That's 4 windows. Make it work. Okay. Unit 4 will take us, it's kind of long. There's more days in this than it was the last time. So you see your test is until the end of November. There's a lot of stuff in here. This is going to be another non-calculator unit. We will get calculators eventually, but not for this one. And this is all about understanding quadratics and more about their graphs and equations. And then the second unit is more about solving. Yes. Wait, so you said me, all right. Here we go. Quadratic transformations. Hey, if you want to be done and get excited for your 4-day weekend, then stop talking. Okay? All right, here we go. Quadratic, parent function, graphs and transformations. This really should not take too long. It is very redundant. But when we redo every transformations lesson, we always have to talk about a new graph. Absolute value, throw it out the door. Okay? We're done with that. Unless you're retesting, then not too far. But we're dealing with quadratic graphs. What's another name for a quadratic graph? Parabola. Very good. Parabola. We're not talking about PSAT. Okay? But you probably have seen this word before. So parabola, quadratic graph, those are the same. We kind of use them interchangeably. But this is what your parabola looks like. You saw this in Algebra 1. It's a big chunk of Algebra 1. And the equation for the quadratic, again, the front page is just about the parent. I'm going to ask you stuff about the parent function on your practice today. So this is what I'm talking about, is this page. Parent function looks like this, okay? Points. You need to know those parent function points because that's what we're going to transform everything based out of. If you know the equation, y equals x squared, and I gave you these x's, why do you think I chose those?
Because they're familiar.
They're familiar. They're kind of easy to deal with. Could you pick whatever x's you want? Sure, but if you have a grid that's going -6 to +10, I probably wouldn't go that on the y. And -8 to +8, I don't think I'd go that crazy with picking big numbers. So suggestion, from here on out, just stick with these guys. Now, the function that we're putting into is x squared. So that means to get our outputs, we just need to square each input. -2 squared is +4. -1 squared is +1. 0 squared. 1 squared. 2 squared.
4.
So you see some symmetry in here. And again, all of these points are on the graph. So this is what I would stick with every quadratic that I transform. I would be doing these guys, okay? Because again, if you start getting to 3, what's 3 squared? 9. You're barely going to fit on the graph. And then if you have any sort of transformation, those points are probably going to hop off. So just make sure that you know which ones to start with. These are our starting points for this entire unit, okay? Yes? Yes? This is what our graph looks like. It's kind of similar to absolute value, as in it has symmetry, it has a vertex, that type of stuff, but it is not like a sharp point and it's got that curve going on. It's like a U shaped. Okay? All right, vocab. I want you to go through, based on this parent function, fill these out. Based on the parent function, y equals x squared in the graph that you're given. different this unit, slightly different, okay? Here's what we have learned in our 12, how many weeks have we been back at school? Not 12.
Less than 8.
8. In our 8 weeks of being at school, we have learned that our people from last year, so the kids who were in my class last year that are in advanced pre-cal right now, okay, do y'all know that next year it's AP pre-cal?
Yes.
It's an AP class. We kind of talked about that. We'll talk about that more later. But they are struggling, and they are not remembering things, and the pre-cal teachers are, like, not happy. And I don't really feel like it's my fault, but I feel like, okay, something's going on, and we got to figure out, like, how to make you guys retain stuff. So what we're trying this go around is we are going to do our practice. Normally we do our practice like Delta Math randomized questions. We put the practice on paper, okay? This time, slightly different. I do have it set up, not for today because graphs are too complicated, but I made a Delta Math assignment for you to put your answers in and check and see if you're doing it right. But you're going to start to see like less stuff that's like so straightforward and kind of more, not conceptual questions, but just that you have to think, okay? Like it just is going to be a little more vague in the instructions and stuff, but you've got to be able to like recall learning increasing and decreasing that we did like a month ago, okay? Because otherwise you're going to get to pre-cal and it's going to be embarrassing. They're embarrassing me right now, those people from last year, okay?
Did you have Austin
Okay.
listed last year?
I don't know. I didn't hear you said. But anyways, okay. What words did you know before I show you? What words could you fill out?
Everything except for 1-1.
Okay, can we do the vertex?
Yes.
Okay, good. Vertex is an ordered pair on the parent function. What is it? 0, 0. Okay, very good. The origin. That's a big deal. So when we do our transformations, focus. When we do our transformations, how that 0, 0 point moves is going to be what our new vertex point is. Okay, could you tell if it was a max or a min? It's a minimum, lowest point. Okay, with the value, in case you see that. Remember, the value is only the y value of the vertex. The vertex is a point. The minimum or maximum value only wants the y, like that highest y or that lowest y, okay? And you can write it y equals 0 or just 0. I put y equals, but it's fine. Okay, axis of symmetry. Hopefully we can do that. What is that? X equals 0. Where does that come from? X value of the vertex. Concavity. Up. Why?
Light, because it goes.
Opening up. Very good. Domain.
Yes.
All real numbers.
All real numbers, or you could write this. You don't have to write both. Either or. Range. 0 to infinity. 0 is included. Some of you guys were not putting brackets on your y value of your vertex. Again, you could write it y greater than or equal to 0. Either or. You don't need both. Okay, so that's just two different ways. Okay, what about the rest of the words? Do we know those?
No. Well, yes.
Increasing, yes.
What's increasing? 0 to infinity. Okay, that's where the graph is going up. So we start increasing. It's at that vertex point. That's where it changes. Okay, so 0 to infinity. So what's decreasing?
Negative infinity.
Negative infinity to 0.
Oh, that's
With parentheses only. Okay, so quadratics, they will do one of each. They'll have one branch. So it's going to be x value of your vertex, where that AOS is, to positive infinity and then negative infinity to 1. And again, they could be either order. Positive, it's not all positive though. Where is it not positive? At 0. So you have to stop at 0. Because at 0, it's at 0. So you have to stop, separate it with a union. This parent function is never negative. Okay, we're just talking about the parent function. Confused about positive. What?
So why wouldn't it be just all of it?
Because at 0, the y value is 0. 0 isn't positive. Okay?
Why can't it be?
Is it a function? How do you know something is just a regular function?
It passes the vertical.
Vertical line test. What about a one-to-one function?
Don't know what that is.
It's not a one
Who is that?
Why?
because only the y value only can be paired with one x value.
Exactly. Or what test? What test can we do?
Horizontal
line test. So one-to-one means your x's and y's can't repeat. Very good.
Could it be
So
a
function is vertical line test. One-to-one function is horizontal line test. Or exactly like you said, you can make sure your y's don't repeat. And if you see we had repeating y's in our table. 4 and 4, 1 and 1. That's going to happen because of the symmetry. So, and again, you can also see this isn't going to pass the horizontal line test. Anybody remember what that tells you? Horizontal line test?
If it's a function. Oh, wait, no.
Not the original. We already know the original is a function. Why do we need to tell us something is 1-to-1?
Got it?
What?
What? What did you say?
Anyone have any clue as to why? Yes. Very good. So if you have a 1-to-1 function, then its inverse will be a function. So is this guy's inverse going to be a function?
Yep.
No, it's not. The inverse looks like this. Is this a function? No. We'll talk about that later. But this is kind of like, again, we're going to try to.
There's a lot of things.
Because it's a reflection over the line y equals x, not the x-axis.
Can something be
Okay.
a 1-to-1 and a function?
Yeah, it's 1-to-1s are always functions. They're like in the big umbrella of being a function, but it's like a subset. So it has to be a function to start with. It does not have to be a 1-to-1 function. Okay? Very interesting. Okay, here we go. We are going to practice before we get into transformations. Stop talking over me. Okay? All right, we're going to label this stuff based on, you got a couple graphs and you got some tables. I'm going to let you kind of try to go through this on your own. Here's what I would suggest. Put arrows on this first graph. Okay? The second graph has endpoints and they are filled in. They're not open circles. This would be like a story, which we'll get to that more like in Unit 5, but there's a lot of like things in the real world that have this parabolic motion. The table, see if you can do it. You may not be able to answer all of it, but you can probably kind of reason your way through it. As far as vocab on here, is there any other vocab words that we didn't do on the front? Hold on, time out. Flip back over real quick. I'm going to add a couple of things that I want you to practice on this front page that were left off. Y-intercept. What's the parent function y-intercept? This is quick, but what's the y-intercept for the parent function? 0, 0. What's the x-intercept? Also 0, 0. What are other names for x-intercepts? You'll want to know this for the next page.
Origin, zeros.
Roots. Zeros. One more.
One more. It's like the
Solutions. How many roots, zeros, solutions, x-intercepts can you have in a quadratic? 2.
What?
You don't have to have 2.
One or
You
zero?
can have 0, 1, or 2. Okay? The parent function only has 1. That happens when that root is your vertex. A lot of times you have 2. There are cases when you can have none. We'll get into that more later. Okay? So if you see these words, these are vocab words you need to know. Okay? All right, ready, set. In just a second. Hey, I filled out this first one. I've been getting a couple questions. X-intercepts, those are ordered pairs, okay? They're 2 separate ordered pairs if there are 2 separate x-intercepts on your graph. It's possible to have 1 or it's possible to have none, but you write them and you don't need a union in between because it's a point and point, okay? You only need a union when you're separating intervals, all right? So there's a little bit different. Your interval with your range, the y value, that maximum or minimum value, it has to have including a bracket or equal to. If you do inequalities, that's really important. AOS has to be x equals. Most of y'all did that right last test, but I did take it off for a couple people. Okay, so look at that there. Domain and range is going to be a little bit different on number 2 because of the endpoints. I think it's probably, it's not that anything crazy. And then we'll talk about the table, but see what you can figure out from the table based on what you got. Okay? Keep going. Here we go. The graph. This graph, number 2. Pay attention on number 2 because, again, there were endpoints. This graph would be a story. We're not really going to do a whole lot of those until we get to the second part of this big unit, like domain and range-wise. But, again, there's a lot of, real-world application with quadratics, which is also why they're kind of cool. So your domain and range are going to be a little bit different there because of those endpoints. And they are filled in, so I use square brackets with all of those. I kind of drew arrows to where stuff came from. You can see there's a lot of important information from that vertex. And then also the roots are really, really important as well here too. Okay? So there was the other graph. Being able to identify from that is big. Number 3 was a table. So I didn't fill out all of it just yet. I will. I kind of want you to know where stuff is in the table. Did anyone figure out where your vertex was?
In the middle.
Yes, in the middle, at the top.
Does it always have to be in the middle though?
Yes.
Does it have to be, well, okay, the middle of the table? Does it have to be like the middle point in the table?
No.
No. How did you know from the table that that was your vertex?
Because that's the lowest your y-intercept.
It was your lowest. How many times did they use the y value of negative 18?
Once.
Only one time. What about all the other ones? They used them twice. So if you kind of look, yeah.
So like for the second one, you know, you said like the range was like both brackets. Like,
Uh-huh.
How do you know like you know, because like for your like anytime there's like a curve, you know, you put parentheses.
That's with increase, decrease, positive, negative.
Okay.
Increase, decrease. But domain and range, it depends on if the graph is like equaling there or actually touching it there.
So how do you know?
Because these were filled in endpoints. I told you they were filled in. Okay? Yes.
How do you know the domain on the graph is all real numbers?
So, oh, with the table?
Yeah.
Guys, side conversations need to be done. People have good questions. With a table, the only time that I assume that my domain is not going to be, was that your question?
Yeah.
What's not going to be all real numbers is if you actually had like a situation. Like look at the situation on this one. It doesn't give you like exactly what it is. But you're talking about seconds and you're talking about feet. Okay, so you're not going to have negative time, not going to have negative height. I don't know anything about this table, so I am going to assume that it is going to have arrows. That would make my domain all real numbers. If it was a situation where it wasn't, I feel like we would be telling you this is a story. Here's what X represents, what Y represents. So that was good. So yeah, again, your vertex, I always say it's like sandwiched in between two repeating Y values. So I can see I have like negative 16 on both sides of the vertex right there. It's the one point, the one Y value that won't repeat. Okay, it's the lowest or the highest. Again, we kind of know that. And then my axis of symmetry has got to be X equals the X value of that. My zeros, okay, there were still 2. Those I could see where the Y values were 0. I write them as ordered pairs. I kind of sketched the graph out to help me with the rest of it. So does it have a min or a max? This graph has a minimum. And the minimum's at negative 18 because that's the Y value. What's the concavity? Up. What is the range? Negative 18 to infinity with a square bracket and a parentheses. Or what y'all said the other way, y is greater than or equal to negative 18. Those are fine too. Increase, decrease, what is going to be the point that you change? Negative 2. Okay, because that's the x value of the vertex. So we're increasing from negative 2 to infinity. Decreasing negative infinity to negative 2. Cannot write. Okay?
The second one is literally the first graph, but like longer.
Yeah. Yeah. It's probably like stretched. Oh, it really is. That's funny. Stretched by 2. Okay. All right. Look familiar. Flip over. Does it look familiar?
Yeah. So.
Number one enemy.
But it's okay. I can do it.
You can do it. Okay, I do want to bring a couple things to your attention that I want you to fill out as best you can, as quickly as you can, what all this stuff is. Okay, we have talked about our transformations A, B, C, and D. They're still doing the exact same thing, you guys. It's still the inside-outside game. The only other thing that is different is this one over here. I don't know why we have to be complicated in algebra sometimes. Like, for instance, calling x-intercepts 4 different names. Why do we have to do that? I don't know. I didn't make it up. But one thing that is kind of specific really only to quadratics, if you look at a formula chart, not that you'll really, I don't know, I guess the SAT might have a formula chart, but like if you look at my Algebra 1 star chart, this will show you, this is your vertex form of a quadratic, which we're going to talk more about that last time. The only thing that is different, instead of using C and D, they use H and K. Okay? Technically, we'll talk about this more next time, but those values represent your vertex, and so they gave them different letters, no idea why, but they do the same thing, okay? H and C are going to be your left, rights. D and K are going to be your up, downs. it's just kind of a formality. You don't have to don't harp on the letters and whatever. But they still do the same thing. The inside, outside, what do they affect? Try to fill this out. Ready, set, go. B is A is less than 0. Okay? Okay. If you don't get all of this, I'm going to put this on Canvas. But hopefully you know. Okay? You can use more abbreviations than me. I just try to make my answer keys for absent people a little bit better. Okay? You do not have to put the letter, but you just need to make sure you know, like, when to do the reciprocal. And then, like, you know, I want y'all to be able to say, like, it went up 5. I don't just want you to say it went up. I want you to tell me how many. So that's why I put, like, my little quotes around whatever the letters.
Hi, Matthew.
Okay?
Scallywag.
I wrote.
I was speaking to Miss K.
Okay, that's not where you were supposed to be.
Robert
So
did not go where he was.
I wrote this right here, that your vertex point, this is important, just like it was an absolute value, you can see your vertex point from the original equation. It's the C value, or again, we can swap out C and H, those are the same. And then we can swap out D and K, those are the same as well. But remember, with your vertex, if you're grabbing that from the point, remember you do the opposite sign on the X, the same sign on the Y. If you don't know what I'm talking about, you'll see it in a minute when we do an example. But you can see the vertex in that. That's why this guy is technically called your vertex form, okay? Another thing, which a lot of y'all missed on the test, what does this guy got to be?
What?
What does your B value have to be? Factored out.
Oh, factor, yes.
Has to be factored out. Which, guess what? It won't be a lot. Okay? And we need to do better than we did on the first test with that. The coordinate rule, if this is like stressing you out, it's fine. I don't write it like that. I usually write it 1 over B times X minus C, A, Y plus D. Y'all already know that. This is just in general how you get the rule. Like A, B, C, and D would be numbers. And so you know that if there's an X minus 5 in parentheses, your table's going to say X plus 5. Y'all know that, okay? It just puts it in general for you. It just says which ones affects your X, which ones affect your Y, okay?
Okay.
All right, here's what we're going to do. We're going to do 2 examples together to get you started. You're going to do 2 on your own, and then there's a little bit of writing practice. And then I will get you your practice packet.
There's 6.
Okay, there's only supposed to be 5. Okay, listen. You need to make sure, I want to talk about through this first problem especially. I don't know why there are 6 blanks on here. It's probably just a typo. You really only need 5 points, but you got to know your parent function points. Okay, so what are my parent function points going to be?
-2, 4.
-2.
1, 0, 0, 1, 1, 2, 4. What she said. Yep.
If you get stumped, you're going -2 to +2 on the X because those are just like the smallest X's we can pick without going in fractions. And then you just square those numbers. We're squaring now. Now, one thing, hang on, hear me out. This starts to confuse people not as much with absolute value. It confuses people more with quadratics and other functions that we'll do later. So what are my transformations here? Let's start by listing those. There are 4. What does a negative do? Vertical reflections. What axis is that reflecting? Reflect X. I don't care. You can write 1. You don't have to write both. Okay? Just pick 1. That's what I'm about to talk about. Okay? The next transformation, the 1/2. What is that? Vertical compression by 1/2. Plus 5 on the inside. Left 5. Plus 2 on the outside. Up 2. So what's your vertex? Can you tell me? It's not 5, 2. It's -5, 2. I always kind of grab that first and then I check it with my table. Okay? All right. Here is the coordinate rule. This is that thing that was on the bottom of the page that y'all were kind of confused by. I do my y's first. I think it's easier. How am I going to transform my y's based on this equation and these transformations? negative 1/2 times y, what? Plus 2. Y'all, that is a times y plus d.
That is A-okay.
Okay? And then my x values, what do I have to do there? X minus 5, because 5 is my c value. Now, here's something that sometimes confuses people. The equation has a squared in it. Okay, yes, they will all have squares in it. I do not have to account for that squared anywhere in here, just like I didn't have to account for the absolute value because I'm starting with these. So this is what's nice about transformations is it doesn't really matter what's going on in that original equation. If you've got the right parent function points, it takes care of all that for you. They took care of squaring your x's from the original. All you are doing is applying those transformations on those points there. So you don't need to have squared written anywhere on your paper. Okay, does that make sense? It's just go straight from the transformations, find your new numbers, draw your graph, find the stuff. That's it. Okay? All right, x's. We'll do those first. Negative 2 minus 5 is?
Minus 7.
Negative 7. Negative 1 minus 5. 0 minus 5. 1 minus 5. 2 minus 5. All right, not as fun one. Fractions. Negative 1/2 times 4. What is that?
Minus 4. Wait.
Negative 1/2 times 4.
0.
Negative 2 plus 2. I think you're just throwing out numbers. I'm not really sure. The final one is 0.
I got it in there.
Okay? Negative 1/2 times 1.
1.5.
No. Oh, okay. You're ahead of me. Negative 0.5 plus 2.
1.5.
1.5. I'm trying to do this in baby steps for those of you that don't like mental math. 0 times negative 1/2 plus 2. 0 plus 2 is 2. There's your vertex point. Check it. Does it match? Very good. Okay. All right. And then here's what's nice also about quadratics is your symmetry. You've already done 1. When you plug that in, what do you get? 1.5 again. When you plug in 4, we've already done that. What do we get?
0.
0. So it's not, the y shouldn't have as much math with it, which is kind of nice there. Okay? All right, graph it. Make sure you guys are giving your graph arrows. Make sure you are making it curved in a parabola. Negative 7, 0, negative 6, 1.5, negative 5, 2. Don't say parabola. That drives me bonkers.
Okay, sorry.
Yeah, you're done.
Okay. So again, it should be curved.
Why is that funny? That's up there with Lucia.
Okay, and then answer the rest of your stuff. Make sure you are doing x equals on your AOS. Doesn't ask for all the bells and whistles here. I kind of just like went to these 4. So keep that in mind
Bells and whistles.
moving forward.
All real numbers.
Also, some of y'all got the absolute value graph on the test that was flipped over. Some of y'all had that range wrong. It has to go least to greatest. Okay? Has to go least to greatest. So negative infinity has to be first. Okay?
I know it's not.
Okay, good. All right, let's start on number 5 real quick. I want to do 5. I'm okay if you skip 6. It has a 1/3 in there, so the fractions get a little bit annoying. But 5 and 7 are good, and then we'll do a little bit of writing so you can get to your homework. What is wrong with number 5? It's not factored, okay? Y'all didn't recognize it last time on your test, so you better recognize it. You will have to factor out a b value, like pretty much always, okay? So how do I do that? For those of you that are lost and don't know how to do it, what do?
You divide by the
You divide by the number that is right in front of x, and you have to divide both things in the parentheses. So really, I'm going to write it above because I'm running out of room. Now, When you divide out that b value, it is still inside the parentheses. This is the double parentheses situation, okay? So I'm going to have 2 right here, open a parentheses. 2x divided by 2 is x, minus 4 divided by 2 is?
-2.
I already got the negative. Close parentheses, squared on the outside. This is how it has to be written. That 2 still has to be inside the big parentheses squared, but away from the x. -7. Okay? What's wrong with number 7? It's not factored. What do you have to divide by? -1. Okay, I want you to try. We're going to take just a few minutes on this because I want to make sure you have some time for your homework because we are, it's a pep rally schedule. Okay, so we have more time than I thought. So I want you to try to do 5 and 7. 6, I'll work out 6, but it gets a little yucky with that 1/3, but it's fine. Okay?
Does the square do anything?
The squared does the shape of the graph, but again, it's taken care of if you know to start with those points. Then all that, the way that your graph is changing is already done for you. But you've got to know what points to start with. Yes.
Okay.
This number 5 is when you have that b value, you took out that b value of 2. Thank you. When you go to your table, some of y'all did not do this correctly on the test. Some of you even factored it out and still didn't do it correctly. You have got to multiply your x's by what? What is your rule for number 5? What? It's an inverse. So multiply your x's by 1/2. You have to do the reciprocal there. That's why this transformation is helpful to you. And then you're going right to. I would cross out the original after you factor it out so you don't even look at that. So 1/2 x, and then if I want to go right to, I need to add 2 to my table. Opposite of what's in there. Okay? What's your vertex point?
2,
Uh-huh. Yes, 2, -7. Very good. That's your. Oh, you always, that C value always is going to flip when it comes out of the parentheses. And then the D value is not in parentheses, so it doesn't change. Flip, keep. Okay? All right, keep going. Do 5, do 7. Let's flip to the back, and we're just going to do the first 2 problems on the back. If you're not done with the graphs, that's fine. I just want to get over these problems and then give you your homework packet so you know what we're doing. These are writing, okay? Hey, good news. Nothing new here. However, what kind of graph are you writing? Quadratic. So you're talking about this is your original function. So no more absolute value bars. You got to have parentheses squared. Alex, close your Chromebook, okay? So write an equation that has been transformed from the parent function. We already got that. This is the parent function. Yay. Vertically stretched by 4. Where does that go?
The front.
Does it flip? No. 4 in the front. Horizontally reflected.
That is a parentheses and then a negative.
Parentheses, negative, followed by another one. Shifted left 6.
X + 6. Plus 6.
Then what?
Another parentheses.
And then what?
Another
And then what?
And then
Squared. Good. Down 4. -4. That's all it is. The double parentheses is kind of a lot. Okay, all right, try this next one, and then we'll check it. I'm going to pass out your homework papers real quick.
wait. It's like that.
And let me pass out your homework paper. This is your homework. First of all, here's this one. Did we do it right? Did I do it right? Think so? Okay. All right. This packet that I just gave you is your homework for the whole unit. So pay attention. We are only on section 4.1, which means it's the front page, which looks like a lot. It's really only 2 graphs and then a couple writing. Then you'll stop when you get to the next page and it says 4.2 because you don't know that yet, okay? So everything, this is for the whole time. There's not room in here, which means you're going to have some paper and you're going to have some work. And I would suggest if you don't have a spiral, go get one because I can't afford to give y'all paper every single day, okay? So go get a spiral of paper, have a notebook paper, whatever. It's less like fill in the blank, like kind of what we have been doing. Again, we want you to think through these things. There is not any, I have a Delta Math for you to put your answers in. Not today though. So you got to go through and use your notes and make sure you know like how to do this. Okay, make a table with points. Graph it. I have some little graph paper if you want to cut some graph squares. You can have some of those. Answer those questions and then go from there. It's just transformations. It's not as much as it looks. But again, when we really, mostly the 4.3 and on, you are going to need your own paper and a spiral or whatever. This will be turned in on the day of the test, so it better be complete. It's on Canvas, 26th, I think, of October. Okay? No, we're not chill. That doesn't mean blow it off until then. This is going to take you forever. Do a little bit at a time, and then it's not that bad. All right, get going.